Routers learn from an administrator. It is called static route. So there is an administrator under whom entire network, or we can say entire router, will be there. So all those routers will learn routing information from the administrators. So actually, in other way, we can say there will be one person, he will feed some information into the router, and that information will be used for the routing decision. So in static routing, we have to add all network locations manually. So everything is done manually. It is like, suppose from one interface we can reach to one particular network that we have to feed manually. So all the things we have to feed manually. And if any change occur, suppose from one interface one network was reachable, now it is not reachable. So administrator has to now update it accordingly in all the routers. So what is the advantage of static routing? It is easy to implement. So you just need some knowledge and you can easily implement it. It is most secure way of routing since no information is shared with other routers. Thus, administrator is responsible for making all the entries into the router. So routers are not directly sharing the information. I'll show a practical demo also for these things. So, but now we can just think in this way. Static routing is something which is manual. A person will be there under whom some routers will come, and all the routing information he has to feed into the router, and whatever he has feed into the router will work according to that. So it is secure. Why we are saying it is secure? Because routers are not sharing information. Who is feeding the information? It is one administrator or one person. So, and what is the other advantage? No overhead or on resources such as CPU or memory. So generally if we'll see other type of routing, this is static routing, other is dynamic routing, which we are going to see in the next section. So in that dynamic routing, lot of messages will be shared, okay, and lot of exchanges they will do, and depending on that they will take the routing decision. So we can say lot of overhead involved in those things, but here there is no overhead. So these are the advantage of static routing. Now what is the disadvantage of static routing? It is suitable only for a small network. It is obvious when one person is feeding all the information into all the information into all the existing routers, it will be more prone to error also. One person, when you are doing everything manually, there are more chances of getting into error also. So if a small network is there, or you can say a small number of routers are involved, lesser number of entry he has to do, and it will be easy for him to manage. Otherwise, if he has to do for more routers, or somehow if he is doing for more routers, it will be it will not be an easy task. So it is suitable only for a small network. If a link fails, static route cannot reroute the traffic. So this is one problem. In the case of failure, it will not take another path automatically. So dynamic routing. What is dynamic routing? When router learns from neighboring router through the routing protocol, it is called it is called dynamic routing. When router learns, it means in a simple language we can say if two routers are there, router A and router B. They both will share the routing information, whatever they have present, by using one routing protocol. So you can say protocol is a set of rules. So with the same rule, it is simple thing. Two persons are talking. So I know one language, you also know the same language. So by using the rule of this of same language or grammar of the same language, we will share the information. Same thing happens here in the router. Router A knows one protocol. Router B also knows same protocol. By using this protocol or the rules, they are sharing the routing information. So routers add network location automatically from the routing information. So here we can say things are automatic here, as the name itself is saying, dynamic. So routing information, first of all, it will get shared among the routers, and then routers add this network location automatically. And if any changes occur in network, affected routers update others via routing information. So this is one good point we can say with dynamic routing as compared to static routing. If any changes or if anything goes down, automatically it will get updated. So as we can see and we can guess also advantages of dynamic routing, it is suitable for all type of networks, unlike static routing. Static routing will use in a small kind of networks, but this is suitable for all kind of network. Automatically build routing tables, unlike static routing where an administrator is responsible for making entry, so in turn it will form the routing table, but here it will be formed automatically. And as we saw in the static routing case, if any failure condition occurs, rerouting of traffic is not possible, but here it is possible. So these are the main advantages of dynamic routing. Now disadvantage of dynamic routing, it is hard to implement. Obviously, when something somewhere more intelligence is involved, it will be hard to implement. So we can say it is a bit harder as compared to static routing. It is less secure. Why? Because unlike static routing, administrator is configuring each and every information, but here routers are sharing their information. So where sharing of information takes place, security will be less. It puts additional overhead, as I given example in static routing also. In dynamic routing, routers will share the information by using the routing protocol. So in that sharing the messages and sharing the routing information, a lot of overheads will be involved. So we can say it puts additional overhead on resources such as CPU, memory and link bandwidth. Now, routing updates. So in dynamic, as we discussed in dynamic routing, routers will share their routing information to other routers. So, and we'll say routing update. Routing update is a mechanism of sharing information with neighboring router. So, with neighboring router, when a router share an information with a neighboring router, that mechanism is called as a routing update. In particular time duration, router advertise its routing information through broadcast or multicast. Depending on the protocol we are using, it will decide it will be broadcast or multicast. So here there is some limitation in a particular time duration. So for every protocol there will be different limitations. For this much time they will give the information, or within this much time they have to retransmit the data or retransmit the routing updates. So in this way, in a particular time duration, router advertises its routing information either through broadcast or multicast. The different protocols have different time intervals, as I told. Routing updates contain all necessary information for routing protocol such as learned network, timers, autonomous system, administrative distance, matrix values, interface details, etc. So these things anyway we are going to see. So in one simple way we can say that routing update contain all necessary information for routing protocol. It contains all the necessary information which is needed to build a routing table into the router. So it can be learned network, timers, autonomous system and interface details. So all such things are needed to build a routing table. So all these things will be available, all this information will be available into the routing updates. Autonomous system. So as I told, in routing update they will send which autonomous system that particular route involves, uh, route route comes into which autonomous system. So autonomous system is a collection of router that share same routing table information. So autonomous system is a collection of routers, or you can say autonomous system is a collection of router which comes under same administration. So AS is a boundary line for routing protocol. Routing protocol mostly will work within an autonomous system, but as I told, it is mostly, it's not always. So but autonomous system is one thing which defines a boundary for a routing protocol. So autonomous system, it can be a company or group of companies. So when we'll say company will have its own routing, its own infrastructure, which is network infrastructure, and it consists of multiple routers. So all those routers will come under one autonomous system. So this is what we call it as autonomous system. So all the things, all the router will come under one administrator. So here we can say under one company all the routers are all the routers are coming into under one company, and it is defined by a numeric value. So it is nothing but ID number, we can say. To distinguish between different AS, Internet Assigned Number Authority provides a range from 1 to 65535. It is nothing but a range from 1 to 65535. Autonomous system number can differ. There are two types of AS, private and public. Private AS number are used for internal network. Public AS number are used for internet backbone. So now, as we told, autonomous system defines boundary for a protocol, boundary for a routing protocol. So here we can say interior gateway protocol and exterior gateway protocol. Interior gateway protocol are used to share routing updates between a router in same autonomous system. So within the autonomous system, there will be multiple routers. So between those two or between those routers, how will share the routing information? That is by using interior gateway protocol. So when we will say interior, interior means within the autonomous system. So whatever routers are within the autonomous system, within the same autonomous system, they will share the information by using interior gateway protocol. Some example of IGPs are RIP. RIP means routing information protocol, EIGRP, IGRP, and OSPF. Now exterior gateway protocol. So it is interior gateway protocol will use interior to the autonomous system. So whatever routers are between the same autonomous system are in the same autonomous system, they will share information by using interior gateway protocol. Similarly, exterior gateway protocol are used to share routing updates between different autonomous systems. One router is in one autonomous system, second router is in the different autonomous system. For sharing routing information between these two, we will use exterior gateway protocol. Example of EGP is border gateway protocol. Here we can see the example. Suppose this is one company, IGPs. IGP one it is showing in blue, other one it is showing in green. So one autonomous system it is showing AS80 in blue. Here it is showing AS50 in green. So within this autonomous system, router 0, router 1, router 2, and router 3 and router 4, when they want to share information within the autonomous system, AT, this router, this 5 router want to share the information, they will use interior gateway protocol, which is written in the blue, IGPs. So by using interior gateway protocol, they will share the information among each other. Similarly, in the green autonomous system, which is autonomous system 50, this 4 router 5, 6, 7, 8, when they want to share the information, they will use this interior gateway protocol. And between these two autonomous systems, so between router 2 and router 6, because router 2 is in one autonomous system, router 6 is in autonomous system 50, router 2 is in autonomous system 80. When they want to share the information, even though they are directly connected, but they want to share the information, they need a EGP, exterior gateway protocol. Why? Because they are part of different autonomous systems. Administrative distance. Administrative distance is the trustworthiness of routing update received from a neighbor router. If a router receives two routing updates for same path, from two different routing protocols, then router will check the AD value to choose the best path. So we can receive for the same path we can have two paths, or we can have information from two sources, but from which one will take which is more trustworthy. So if we are getting from different routing protocol same information, we'll check the AD value to choose the best path. AD is a numeric value from 0 to 255. If one update has lower AD value than other, and the route with the lowest AD will be placed in the routing table. So lower AD will be trusted as more trustworthy. The lower AD value is more believable by router. 0 is considered as the most trustworthy network, while 255 is considered invalid route and will be never used. Here it is showing list of AD administrative distance. Direct connected interface, it is 0, so most preferable. Static route is 1. EIGRP, it is one routing protocol. For now, you can consider it as IGRP. OSPF is also one routing protocol. RIP, routing information protocol. External EIGRP. 255 means unknown, unreachable. As we can see it, invalid route, and it will never use. Now metric. If two routing update for same network has same ID value, then metric will use to choose the best path. So suppose we have received two routing update for the same network have same ID value, then metric will use to choose the best path. Metric is a measurement to calculate best path. Route with the lowest metric will be chosen. Different routing protocol use different metrics. It may use single metric or multiple metric. For example, EIGRP uses bandwidth, delay, load, MTU, while RIP only uses count or metric. So this RIP and EIGRP related things, EIGRP thing anyway we are not going to see, but RIP, how it uses hop count as metric, we'll see that. So the summary is metric, every routing protocol will calculate it in its own way to calculate the path, cost of the path. Cost, when we'll say the cost, we'll say how effective will be that path. So if the cost is less, that path will be preferred over a more costly path. So here is the list: EIGRP, bandwidth, delay, load, OSPF, cost, RIP, hop count. Now there are, so this is nothing but metric, and what is the how it will calculate the metric depending on what criteria. For various protocol, it is different things. Now it is routing protocols. So there are different category of routing protocol: distance vector, link state, hybrid. So this we'll see in the next video. Thank you.